going to now be talking about Gaussian splatting. And ladies and gentlemen, take out your phones. We have a question for you. We want to find out how familiar you are with Gaussian splatting. So you use it, you've explored it, you have already heard it, or you have no idea what is it. And our upcoming panel is going to discuss its use in the tech and creative industry, but let's just paint that picture. What kind of experience you have with the Gaussian splatting? Okay, let's take a look. Okay, 37%, 38 heard of it. 28, roughly 1/3 explored with it. 1/4, more than 1/4 is already using it. No idea what it is. Perfect. Please keep on sending those poll votes, but also keep on sending those questions because our next panelists are going to take them and address them. And having said that, let me welcome on stage the moderator of the upcoming panel discussion, Michal Goa. Let's give it up for him, ladies and gentlemen. Michal, welcome.
Thank you.
The stage is yours. So is this iPad.
Thank
Take
you so
it away.
Should I introduce the rest of the?
Absolutely.
Okay. Welcome, Michael Rublev from radiancefields.com. He's the researcher. He certainly is able to explain what does it mean, Gaussian splattings. Mindy Li from Xgrids. You can meet them outside in the booth. Welcome, please. Sato from Godzilla Pro. He will tell you how to actually share Gaussian splattings. Welcome. And Tomas Barnas, you already know him. The photogrammetry VR AR professional with real applications of Gaussian splattings in commercial world. So, thank you guys. Take a seat. Okay, I think I have not butchered your names or your companies, so I hope the introduction went well. There was only like a 10%. Only like a 10% of people that have no idea what Gaussian splatting is. I think it's very important to start with that topic because most of the people here they already touched photogrammetry. So maybe it would be good just to like very briefly compare it and just to explain from your own views, what do you think the Gaussian splatting is and how it can help the industry? Maybe you can start, Michael.
Yeah, definitely. So Gaussian splatting, the full paper name is 3D Gaussian splatting for real-time radiance field rendering. It is a way to render a radiance field in real time. So if like during the course of this talk I just refer to radiance fields, I'm including Gaussian splatting inside of that. And basically what Gaussian splatting allows you to do is you are able to take just a normal series of 2D images or normal 2D video, and you're able to then reconstruct very lifelike 3D from that. And so radiance fields are able to show what are called view-dependent effects, which basically, you know, if you were walking around last night after the rain and taking a look at like the stone and the stone ground, you could see the way that light bounces and reflects, and we have this very natural inclination of what that should look like in the real world. And Gaussian splatting and larger radiance field representations are able to model these effects, and so we can see glass and light and shadows and things that might be traditionally tricky with say like photogrammetry. And it's become an extremely exciting research topic since the introduction of Nerf in 2020, and there's been a lot of additional radiance field representations, but definitely Gaussian splatting has really captured the industry's attention.
Perfect. Is it safe to say you're a researcher of the 3D Gaussian splattings?
I would say that I try to keep up to date the best that I can with the state of the research. It's not uncommon at all anymore for there to be 5+ papers every single day that releases just specifically within Gaussian splatting, but that also does not include Nerf and some of the other methods that are in the radiance field world. Yeah. So I wouldn't say I'm necessarily a researcher, but I've become very friendly with this.
Thank you very much for stealing my question, because I was wanting to ask you how often there is a new paper, because
yeah,
it's very often. So you said like every 5 days or so?
5 every day.
Oh, 5 every day?
For just Gaussian splatting, yeah. Yeah,
okay,
it's very
so
active.
don't worry about Gaussian splatting. you wouldn't keep up with that. Mindy, please, your perspective will be different because you are producers of softwares and the hardware. So how do you see, and what was the idea behind, because you produce SLAM scanners, right? So when and how the idea came to actually integrate it with the Gaussian splattings?
Yeah, firstly, Xgrids is a company manufactured SLAM scanner, and we found that SLAM scanner is a way to quickly capture the reality. But in the past, we used LiDAR and combine different sensors together. When Gaussian splatting can, we find that's the best way we can find at this moment to represent the reality. And we find you can use the photos and videos to do the reality capture, but it's not efficiently enough, especially for those spatial modeling things that you want to scan a relatively large scale set. But if you use SLAM scanner to do that, you can to do that reality capture in a mobile way, so that you can do infinite, technically speaking, it's infinite scans for the whole world. So that's why we specialize in SLAM, and we combine the SLAM technology together with the Gaussian splitting. And we find that LiDAR itself can help the Gaussian split itself very well to help the photos and the poses can find their position well. So that's why the results can be cleaned and structured very well.
Mm-hmm. Perfect. Josh, from your point of view, because we all know that the sharing, displaying, and just working with 3D assets at all, it's very challenging task. Even if you want to do it online, especially. So, what were the challenges for you to be able to build a platform and to be able to share Gaussian splattings?
So firstly,
sorry, it was for Josh.
Sorry.
Sorry, Mindy.
Can you hear me? Okay. So yeah, one of the main challenges of developing Gaussian splatting web-based viewer and editor is the file size of Gaussian splats. And by default, the Gaussian splats are so huge, it's like multiple gigabytes, and it's very tough to share all these large files on the internet. So compression is one big important factor for enabling Gaussian splatting web sharing. And I think Xgrids are already doing a great job at compressing all these Gaussian splat data. And also there's ongoing efforts right now among the industry to have a Gaussian splatting file format standard to make all these Gaussian splatting more available to all these clients, many companies, to be able to utilize Gaussian splats on the web with only a few megabytes. So that's something in the direction that's been discussed right now.
So is the goal to get it working in any device across all the platforms, or?
Yeah. So one of the advantages of Gaussian splats is that it can be executed on almost any devices like smartphones, tablets, of course desktops and laptops, and that's because Gaussian splat is based on conventional rasterization on the GPU. So it's rasterization along with alpha blending. So there is no costly neural network or AI. It's just traditional rasterization in the original GPU pipeline. So again, you can use it for phones, laptop, almost any device you have.
Thank you. Tomas, everybody knows you're photogrammetry king. If 2D is against my religion, I think photogrammetry for you is like a holy grail. What broke inside of you that you just started using also Gaussian splattings?
Yeah. So the possibility to combine these two things, because I'm never saying or like this is the only thing you're going to use. We are using also laser scanning and everything, but I still love photogrammetry as it is for the results you can get. But generally, when you see what I was showing also in my presentation, that how much you can achieve in a way simpler way, and this is like not about like just trying to do something faster, but it's about the possibilities. So really combining photogrammetry and Gaussian splatting into one thing, it's amazing. And on top, I would say, like, because with Michal, we had a lot of discussions always when the nerfs were there, like the first ones, and I was super against, because we tried to use them anyhow. Then putting them in Unreal Engine, it was killing all the GPUs. It was like super heavy for anything, and the results were worse. So I was kind of like against. But then the development of Gaussian splats really brought it back and gave us the possibility to create way cooler things than I could ever imagined before.
When the first instant NGP came and the first papers about the nerfs came, I did a post on LinkedIn saying in a headline, "Photogrammetry is dead." And Tomas was instantly like, "Michael, don't do that. Please don't ruin my business." So that's why I asked him what broke inside him. Guys, I'm really glad you're asking the questions. I would like to touch as many as possible. So let's start with the first one. What is the best way to get started with Gaussian splatting? I think Michael would be
definitely. So in terms of taking a look at getting started with on like the capturing side, you can say a lot of these data sets will work with existing photogrammetry data sets. So if you already have something like this, you're able to put it into some of these pipelines, which I'll get to in just a second. But in regards to the actual data in which these different radiance field representations really love, is they really love having sharp images and sharp frames. So any motion blur that is introduced into a still image, you should actually remove prior to processing it. It actually will do more to damage the scene than it will to aid. So it's really a much better idea to just curate a very well-selected set of images as opposed to just doing more images altogether. In terms of getting started on the pipeline side, depending if you're looking to train locally, there's some great options like PostShot, which is free to use in beta right now on Windows, as well as Nerfstudio, which is where I think you can currently get the highest fidelity. It gives you a lot more manual control. If you're trying to do very large-scale captures, then obviously processing through Xgrids is an amazing platform as well. If you're looking to go strictly cloud-based, there are platforms like Teleport from Vario, who just introduced their 2.0 version yesterday, and you're getting really great results from there. If you have an iPhone or Android device, you want to just capture everything locally on your phone, you can use Niantic Scan as well. And for just getting started as well, I would also suggest you don't need to go and try and capture an entire city or a location at the first time. Maybe you could start small, maybe take a small object, put it on a little thing like here, and just passively walk around it, take some images, and put it into one of those pipelines.
Perfect. From the very beginning, I think that the most concerns about Gaussian splatting was about the accuracy, about the scale. But what you did, Mindy, with Xgrids, did you just decided to break all the biases around the Gaussian splattings? Because like the combination of SLAM and Gaussian splatting, I think it's brilliant. So was actually the market biases the reason why you did this, or did you just came up with this idea to connect SLAM with Gaussian splattings?
Very good question. So firstly, we came from that surveying industry is our starting point. And the first thing we must to tackle is accuracy. And then we find that Gaussian splatting itself is really a good way to do the visualization part. And but when we combine the LiDAR data together with the Gaussian splats, we also tackle with the things with the accuracies. And the first requirements posed by our customer is that whether we can do measurements based on that Gaussian splats. So that's why we combine the point clouds accuracy together with the Gaussian splats. We align them together accordingly. So that's why we can conduct the measurements based on that centimeter level accuracy to see that it's like if you can measure a table's length or height in a Gaussian splats in an accurate way and easy way, which is totally different from that point clouds do in some very professional measurement software. So that's the things we try to do, use a more visualized way to do the measurements and try to tackle the biases that Gaussian splats cannot do measurements. That's just because that its backgrounds or the techniques behind Gaussian splats is an accurate point clouds.
Michael just said several ways of how you can start actually with the Gaussian splats and or splattings, and you can see that you can just pull your phone and start with it. So Josh, I think you must have seen all the possible data sources for Gaussian splattings. I understand that your task is not to process them, but to actually show them. But since you have seen all those possible sources of Gaussian splattings, what do you think? It's actually the question from the crowd. What do you think is working better? Is it images? Is it videos? Is it 360 videos? What do you think is working best with Gaussian splatting?
Yeah, so currently our platform is fully web-based, and it's only for editing and viewing, but our plan is to make our platform fully end-to-end, meaning that you can not just edit the scene or viewing the scene, but also you will be able to train Gaussian splats on the web. And in fact, there is already an open source solution. It's called Brush. It's written in Rust and utilizes web GPU, so it's fully cross-platform, where you can train Gaussians, not just on Windows, Ubuntu Linux, also Mac. So you can utilize all these NVIDIA, AMD GPUs as well. So yeah, I think we are going in the right direction where we can use all these different GPUs or these different machines. So yeah, web GPU-based platform, it's something that we are aiming to develop in the future. And as for the capturing devices, you can use all sorts of consumer devices such as smartphones, obviously, and then you can use 360 cameras. You can also professional cameras like DSLR or mirrorless cameras, and then of course professional LiDAR scanners of Xgrids. So there's all sorts of capturing devices available for generating 3D Gaussian splats already, and there is no need for special hardware for starting Gaussian splats. You can just start with your own phone, just take a short video around the object, then train Gaussian splats.
Michael is eagerly looking at me, just wanted to say something. Feel free, guys, to jump into each other. Like the fight is actually the best way for engagement on social media. So let's.
Yeah. So comparing like photo to video for the import, the input sources, it really just comes down to where you have the sharpest frames. You know, because if you take a video, you just want to really review and you want to like put into like FFmpeg or get the original like actual input images. You just want to really cull through and make sure that the images that you are going to be putting in from that video are going to be sharp. Because it's very easy to use video as an input, but just make sure that the actual base images that are being pulled out of that video are still going to be very sharp, because that more than anything will impact your reconstruction fidelity.
Thank you for adding that.
I need to jump there as well. So
you
I wanted to exactly say the same, because like that's a general question, and it was many times also around photogrammetry, like images, videos. Why people want to use videos also for Gaussian splats? Because it's easy, straightforward. You don't have to think. You just run. And the problem, generally, like Gaussian splats and photogrammetry, is about keeping the overlaps and keeping the angles. So what you don't do with video, like with camera, if you're taking pictures, you take a picture of a table, then you make 5 steps, and you make a second picture. You ruin the way how it should be processed. If you make video, you never make that mistake. So the video is helping you to keep the workflow as it should be done, but it doesn't give you better results. It just gives you like better pipelines. So the images as itself, they are always sharper. Mm-hmm. Right?
Yeah.
You want to add something?
Yeah, no, exactly. The sharper, the better. And there's actually a platform called Reflect that offers something called sharp frames, where basically you just upload a zip file of it, and it'll rank all of your image sharpness by each image, and you can kind of do like auto culling. And you could also see in across like a timeline view of like where the actual images are being removed from, so that if you are missing some level of overlap, then you can kind of just make a choice at that point of what you want to do.
Perfect. Tomas, when I introduced you, I said that you're one of the first that actually were able to commercially use Gaussian splattings, and there was a question about using it in VR. Can you tell people about the project?
Yeah, exactly. So as Josh was already mentioning, like you can use Gaussian splatting on the phones and VR. If you have VR, it's generally like Android applications, so it's the same like a phone, more or less. But before this was even possible, there were still possibility of streaming the Gaussian splatting into your Googles. So even if the performance or if the headset is not supporting it natively, so you can't upload it there, you can still make it run on the PC and stream it into VR, which is not a problem at all. So that was also one of the things, like coming to the first question, what made me think of like, okay, we need to use it almost in every project, because you just combine it with anything you want, or you can use it just as it is, like Gaussian splatting. So yes, it's possible to use it in VR, and it's a pretty straightforward pipeline.
I also want to add something. These days, I also bring over VR demo here, and we've already tried to put some Gaussian splats in Apple Vision Pro, Quest 3, and Pico. So we found that Apple Vision Pro really have a good GPU on board, so that's why his visualization effect is the best. And we still can use some other streaming methods to do the things with that Meta Quest 3 and the Pico things. So you can also see it's a very immersive case with that Gaussian splats because everything is so real. So the only thing you need to try, you need to tackle is that to make all the data more compressed compared with photogrammetry things or the conventional Gaussian splats format. Yeah. So it's possible, and it still have space to improve.
Perfect, perfect. Josh, where do you see the biggest limitations of Gaussian splattings right now?
Yeah, great question. So in terms of quality of Gaussian splat reconstruction, I would say, yeah, all these capturing methods are, these motion blurs, differences, and in exposures. Yeah, these are all adversarial factors for making high-quality Gaussian splats. So a technique in photogrammetry can definitely be utilized in also Gaussian splat capturing. So yeah, if you have knowledge and experience in photogrammetry, it definitely helps in constructing and generating high-quality Gaussian splats. So yeah, that's the one of the limitations for the Gaussian splats when it comes to generating high-quality Gaussians.
Yeah, and I'd say that one of the historical limitations of Gaussian splatting was basically the original version of Gaussian splatting would assume a perfect pinhole sensor, so it would mean that it would really struggle with like fisheye lenses, and that would just kind of like be turned off to that. And so NVIDIA actually released a paper called 3D Gaussian ray tracing, which is not Gaussian splatting. It's a pure ray tracing based radiance field, which takes away that restriction. They then came out with another paper called 3D Gaussian unscented transform, which actually brings these secondary lighting effects and pinhole, and fisheye support to traditional Gaussian splatting. So now this has been solved from these two different papers, and the second one goes into normal Gaussian splatting. So that now really opens up a lot more use cases for like robotics applications, for instance.
I think you people that are familiar more with Gaussian splatting, you must remember the first paper from NVIDIA. It was called Instant NGP. And there was this video with a woman and NVIDIA claiming that you can get perfect reconstruction of the person from only 4 images, which I honestly think it was a bullshit. But it's sorry, NVIDIA. Are you here? But my question is to Tomas, because you've been testing a lot of data sets. It's coming from here, the question. Do you think it's better to use more images with less quality or less images with higher quality?
Yeah, this is this balancing in between. Like if you do too less images, then you don't get a good quality. So it needs to be a balance. Like the amount, it's hard to say. Like you need to do a good amount with good overlap and good quality. Yeah, but like it's no. If we do it in extremes and we say like overdoing pictures, so making like too much, it's bad for the results. Like anywhere, because if you have like too much of input, it's too many overlays, and that multiplies possible mistakes or misalignments, which are making the results worse. So it really needs to be like a good amount.
I didn't want to make it sound bad saying that about NVIDIA, because NVIDIA is doing one of the best jobs with all this new technology. It was only to really point out the importance of taking the images, because it would be very bad if you thought like you can get poor images, poor video or anything, and you will get perfect results. It's always shit in, shit out, right? So, yeah. So what's like the best workflow, do you think, Michael, to just capture some object?
Yeah, I mean, for me now, I go back and forth between photo and videos, but now I just mainly shoot still images, and then I've seen some extremely high fidelity captures going just from normal 2D mirrorless camera into reality capture, and then into either like post-shot or Nerfstudio for just like general like capture, I would say. And then it just really depends on like what it is you're shooting with. So for instance, if you're shooting with your phone, it could be a different pipeline versus with like an Xgrids scanner or something along those lines.
Mindy, you must have seen tons of different use cases for either your SLAM or also for Gaussian splatting. So where do you see the biggest potential? Which industry do you think is going to benefit the most?
Yeah, that's the thing I observe all the time. So firstly, we find most of the requirements comes from the AEC industries. So that's just because we use that for spatial modeling. So that AEC industry, so-called architecture, engineering, and manufacturing.
Construction.
Yeah. So that's the things people will buy for 3D assets things, and they want to know exact 3D structures of the whole thing. So people also do the scanning and the reality captures again and again very often. So that's I think it's the very basic industry who needs that Gaussian splatting for their reality capture things. Then we find the filming industry and gaming industry increases very quickly. And this month, we go to NAB. It's National Association of Broadcasting. It's the biggest show for the filming and the broadcasting industries. We find that we are the first guy to attend this kind of show to do that reality capture things with Gaussian splatting. And from that pre-scouting to the pre-production and virtual production and VFX, all the workflows can use the Gaussian splats to enhance their workflows, to increase the efficiency, get a better quality, and cut cost.
Thank you. Josh, you mentioned already that your goal is to create the whole pipeline of working with Gaussian splattings. Is there on the roadmap also working with different 3D assets, just combining with the Gaussian splatting, like, I don't know, like 3D CAD or BIM models or?
Yes, so one of the advantages of using Gaussian splats is that since it utilizes traditional rasterization on the GPU, you can use what's called depth buffering for blending or fusing with traditional textured meshes. So you can import textured meshes like 4D BIM model from Revit, for instance, and then you can fuse those models with Gaussian splats. So it's already possible. You can do that technically, and it's in our pipeline in the future to implement such functionality.
Tomas, since I'm saying this third time, but you're that photogrammetry guy, so please tell me your point of view. How do you see Gaussian splatting replacing or complementing, or how do you see the position of Gaussian splatting in next years compared to photogrammetry?
I see these technologies merging, simply said. Like the target would be that in a certain point you would not really think of that, because the pipeline is more or less the same, the processing is more or less the same, the output is different. So it's kind of, for me, it's becoming one technology which has just two different results. And I think also the software is processing, the photogrammetry will be slowly adding all these Gaussian splatting supports, and they will enhance the results. So I think it will end up as one big thing which will grow together.
Michael, when do you think that the actual hype around 3D Gaussian splattings
happened? When it began? Yeah, so we're actually coming up on the 2-year anniversary of the paper's publishing. It came out in late April of 2023. And for the first couple of months, nobody really paid attention at all to it. What really changed was it won Best Paper at SIGGRAPH in 2023. And it was pretty much like overnight, the amount of like excitement of it just really kind of went through the roof. And so the two, the researchers from INRIA, George Kapanis and Bernard Kerbel, they released the code, and it just kind of went from there. So August 2023 is when it started to really become popular.
Thank you. Mindy, what is on your roadmap for next year's? Where do you see the Xgrids working with the Gaussian splattings? What are next steps? What people can expect from your development?
So firstly, we want to make a better hardware for easy scannings, because that always people said that LiDAR is too expensive, but there are many people want to use that for the spatial modeling things, not only to do the objects or the single points. So better hardware. And another thing is that the ecosystem things, because we find a limitation of Gaussian splatting at this moment is that it cannot well integrated with the traditional 3D workflows very well. But so these days, I work closely with the partners like Yoshi very well and Tomas together to see how we can develop more plugins, SDKs, more softwares, and even implemented web GPUs for more workflows integrations. So that's the future chance.
Georgie, if you had to pick just one solution to recommend how to produce nice enough Gaussian splattings, please don't say Xgrids because it would look bad. It would look like a commercial set, but we don't want it to be. So please tell me one solution, maybe a free solution like that people can use freely. So.
Yeah, that's a great question because there are a lot of software solutions or open source projects that's out there that let you generate Gaussian splats already. I would say, so if you're just a hobbyist or entry-level user, I would say Scaniverse, it's a phone app which lets you generate 3D Gaussians on device without any requirements for any crowd processing or any powerful GPU on the local machine. So you can generate Gaussian splats on your phone locally from just a short video. You can just capture a short video using your own phone, and you can do that already. So that's a great solution or app as an entry-level Gaussian splatting trainer and viewer.
Perfect. Tomas, one last question. You do amazing big scenes, photogrammetry scenes. What is the biggest scene that you actually combined with the Gaussian splatting and you saw the perfect results?
Yeah, that's like what I was also showing before. So we had like almost 100,000 images in the scene, which was previously processed without Gaussian splatting, but as it was developed, we just enhanced the surrounding, and then putting it together in Unreal Engine created like an endless feeling. So that's like for me this main benefit and the scale. So you create like endless scale and it still looks great because you have it like from the center of the interest.
Perfect. Thank you very much, guys. I hope you got some new information or maybe inspiration. Thank you, Michael Rublev.
Thank you.
Thank you, Mindy Li, Josh Sato, Tomas Barnas. Thank you.